Okay. Thank you very much for coming. Good afternoon, ladies and gentlemen. I will now give a short presentation on the long-term trends of radionuclides in foodstuffs. And these long-term trends in foodstuffs, they are quantified by so-called ecological half-lives. And ecological half-lives, they describe the degrees of an activity in an environmental medium due to natural processes. And such natural processes are, for example, fixation by soil particles and reduction of bioavailability. This may cause that with time the uptake of radionuclides via the root is decreasing, or migration into deeper soil layers, or the loss of activity due to soil erosion. The point is that the radioactive decay causes an additional reduction of the activity, maybe in plants, as a result of uptake by the root. So, in many cases, nearly all cases, the decline of activities in foodstuffs is faster than the radioactive decay. And I will show you some examples. These are ecological half-lives which were derived from the analysis of monitoring data in Europe from weapons fallout and post-Chernobyl. When we look at this figure, this shows the season deposition from nuclear weapons testing and Chernobyl. Nuclear weapons testing in the atmosphere was performed from the mid-40s to mostly 1963. After 1963, most weapons were tested underground and only a few tests were made in the atmosphere. You see, this is the deposition per square meter in these years. There's a peak in 63 and then it declines. And then it goes up in Europe due to the Chernobyl accident. So if we look now here at the seasonal activity in milk, this is in South Germany, but this doesn't matter so much. This is similar in nearly any country. We have a nice decline from the late 60s to 85. This is a year before the Chernobyl accident. It's nearly a straight line, it's a logarithmic scale, and the ecological half-life is 4.5 years. If we include the decay, then it's 3.9 years. It's a decline of the activity in milk. And this is the same from 89 to 99. 3 years after the Chernobyl accident, we have something like 5.9 years. And including the decay, it's 4.9 years. So this means this results agree reasonably well. These are mean ecological half-lives measured in Belarus, Russia, and Ukraine. I will not go into much detail, but you see here the variation is larger, depending on the soil type, etc., and it varies from 4 years to 40 years, depending on the circumstances. We can see that for peat it's a bit longer. In this case, Standalone is about 10 years, 5 to 20. So in any case, with one exception, it is always faster than the decay. This is another table. Sorry for this table. It's not necessary that you remind all these numbers. The message is that this ecological half-life may be pretty fast. And if you look here, it's in the order of a few years. And in the second period, it's a bit longer. This has been observed after the Chernobyl accident. And in the beginning, one could observe, so to say, two components, a fast one and a more slower one. But all these factors cause that the decline in the resulting foodstuff, it's much faster than due to the radioactive decay alone. And this is a key message. This is something from Tim Smith from UK. He has looked on several products like fish in UK, fish in Norway, and vegetation and water, and also there's also a nice decline, faster than the decay alone. And again, in the first few weeks, there are fast processes of absorption, vertical migration, and biological uptake, and then the decline slows down. And again here also the decline is much faster than due to radioactive decay alone. There are some circumstances where it's also the case, but where it's not so obvious. This is, for example, cesium in wild boar collected in South Germany. Wild boar is also an issue in the area of Fukushima. The wild boar have reproduced very well because they are no longer systematically hunted at some places. And one could find pretty high levels of cesium in wild boar and also slow decline. Here it's difficult to really identify this decline, but statistics say there is one, and I will in this case believe the statistics, and these statistics indicate an ecological half-life of 10.5 years. So it's a slow decline. A more decline is here. This is the time dependence of cesium there for brown rice in Japan from 1960 to 2000. However, we have to be here a bit careful in the beginning of this period, because during this period we had still atmospheric nuclear weapons testing, and though in this period, let's say in the 60s, these results are also influenced by the ongoing deposition of cesium to the leaves of the rice, and so these values are higher. But then during the 70s it decreases and it remains more or less stable, at least the statistics say more or less stable during the 80s and the 90s. The effect of Chernobyl cannot be seen in Japan because it was too far away and only little deposition occurred. So, in summary for this ecological half-lives, if we look for plant and animal food products on agricultural land, we have approximately ecological half-life of 4 to 6 years. We have seen there are variations. It always depends on the circumstances, but the point is 4 to 6 years is much faster than radioactive decay alone. In pasture we can see often two components. in the first years, something between 1 and 4 years, and then afterwards, the decline slows down to levels between 5 and 15 years. One has also seen a slower decline for vegetation on peat and mineral salts which are low in clay and minerals. Then the decline is less pronounced. For forest products, where the availability of cesium is usually high due to the low clay content, due to the low potassium content, and often due to the low pH value, the activity levels in forest products are more persistent, and an average has been found about 12 years, but it can be also much longer in some areas.